Example 6.2 is asking us to find the equations of any horizontal tangents to the curve. We might also be asked to find any tangents that are parallel to the x-axis. Either way, what we're doing is we're finding a slope that has a gradient of 0. So we've got our curve here, which is a cubic, x cubed minus 3x squared minus 72x plus 19. First of all, we need to find the slope function. We don't have a point of interest yet, so we just start with the slope function and we just use our rules. So the 3 comes down as a factor out the front, and the index of 3 becomes a 2. Negative 2 times negative 3 is negative 6. The index decreases by 1 to give minus 6x. And 72x derives to negative 72x derives to negative 72, and 19 derives to 0. So make sure you can derive that using the rule reliably. The next piece of information is probably the most important part in this, that the horizontal tangent, or the tangent that's parallel to the x-axis, has a slope of 0. So therefore we set the derivative to 0 and solve for x. So you can see that the derivative is a quadratic. When we've set it equal to 0, we can factorize it and solve for x. You should be able to factorize that any one of a different number of ways. I've done AC sums to B. You could do quadratic formula. You could solve it via equation solver. Either way, we end up with x being negative 6 and negative 4. So what that means is, at the point x equals 6 and at the point negative x equals negative 4 on the graph, the tangent is horizontal. So we'll either be looking at something like this or something like this, depending on exactly which way the curve goes. So from there we find the corresponding y coordinates. So when x equals 6, y equals negative 305. When x equals negative 4, y equals 105. So from there, it seems like we're taking a shortcut, we're just concluding. So therefore, the equations of the horizontal tangents are y equals negative 305 and y equals 195. So the question might be, why didn't we have to sub it in using the y equals m outside of x minus x1 plus y1 formula? And the reason is because we're dealing with horizontal tangents, whatever the, whatever the y coordinate of that point of contact is, the equation is going to be y equals, let's call that y1, y equals y1. And if this is x2, y2, then the equation of this line is going to be y equals y2, bearing in mind that the equation of a horizontal line is simply y equals whatever the y coordinate is. So we've found our equations of the horizontal tangents. In the next video, I'll go through example 6.3 and you can write in the little bit that I left out of the booklet.